For today's lesson, and today and tomorrow, we're going to be working with doing a lot of factoring. And so we worked on the reminder of the basics yesterday on Friday. And so let's go to some where we have ax squared plus bx plus c. So let's do a little bit of that factoring today. And I'm going to show you a couple different ways to do it. And you can pick which way you would rather do it. And I think I might lean you one way or the other. How many of you did box method for factoring? If you remember that, doing it in Algebra B, where whoever your teacher was, Miss... What's that? Okay. How many of you did slide and divide? You know what the slide and divide is? All right, so I'm going to go over both, but I think I'm going to encourage you to do slide and divide because I think it's a little bit easier to do.
That's for like factors. This one.
Right.
This one's that.
That would be guess and check. Okay. All right, so I'm going to show you that you can do the, you can guess and check your way through it. I'm sure probably the way that Maria may have learned it was probably doing that. Did you learn it where you just wrote down the numbers and then looked at adding them up and you don't know? Okay, all right. When I get done, and I'll see what you've done. But I asked Cynthia, you know who Cynthia is? We were talking about it this morning and the way she does the guess and check method, but I'm going to show another way because that can take a long time sometimes, depending on the situation. All right, so we're going to take number 1 here, and we're going to factor it. So it says 2x squared plus 13x plus 15. All right. And I'm going to do this 2 different ways. Okay. First way I'm going to show you is what's called the X box or box method for doing it. Okay, so some of you may have seen this method, and when I start doing it, you might like, oh yeah, I remember doing that. Okay, and if you like that the best, then you can do that. But I'm also going to show you what's called slide and divide, which I actually like better, and I'll tell you why I like it better as we go along. All right, so in the X box method for factoring, when you have ax squared plus bx plus c, the first thing we do with this is that in the top of this box, we're going to multiply a times c. Okay. So in this case, a is what? 2, and c is 15. Okay, so 2 times 15 is 30, right? Okay. In the bottom of the x is the value of b, the middle term, which in this case is 13. So what goes in the sides of the x is the factors of 30 that add up to 13. So let's see, factors of 30, 1 and 30, 2 and 15, 3 and 10, and 5 and 6, right? Which pair of those numbers adds up to 13? Okay, 3 and 10. So I'm going to put 3 here and 10 there. Okay. So I'm going to make a box. This box has 4 squares in it. Now the numbers that go in the, excuse me, what goes in the square, the first term goes here, 2x squared, in the upper left, and the last term goes in the bottom right. And then the other 2 boxes, we're going to put 3x and 10x, but it doesn't matter which one goes where. Now, what we've got here is, these would be the 4 terms if we actually FOILed our answer. So what we do now is we're going to factor the greatest common factor from the rows and the columns. Okay, how many of you remember this now? It's starting to remembered a little bit. Okay, a couple people. So what do 2x squared and 10x have in common? Okay, they have a 2 and an x. 3x and 15. 3. Okay. Then we go vertically. 2x squared and 3x. X. And 10x and 15. 5. Okay. So when I factor this, I would get 2x plus 3 and x plus 5. Okay. So we use the x to do the factors of 30 that add up to 13. And then with the box, then we use that to find the actual factors. Okay, that's called the X box method. Morgan, please.
Oh, I'm not checking. I'm not using it.
Okay. Now I'm going to show you what's called the slide and divide method. Then. All right, so let me move this down here. Okay. Now, in the slide and divide, the first thing we do is we multiply A and C. Okay? Which the same thing we just did. We actually multiplied A and C there. And when we do that, we get x squared plus 13x plus 30. So that becomes C. All right, my last term. Okay. All right. The second thing we do then is we are going to factor that. So what do we get when we factor x squared plus 13x plus 30? What are the factors of 30 that add up to 13?
10.
Okay, 10 and 3, right? Oh, hey, we just used those numbers. So x plus 10 and x plus 3. Okay. Now, all right, so we're using numbers we just used. Okay. Now what we're going to do is we're going to divide the constants. What are the constants? What are the constants? 10 and 3, the numbers. Okay. All right, we're going to divide them by A, which in this case is what? 2. Okay. So we have x plus 10 over 2 and x plus 3 over 2. That's the value of A. 2x squared plus 13x plus 15. Okay, A was 2. Okay. Step 4, we're going to simplify it. So we get x plus 5, and can I simplify 3 halves? No. Okay. Now, here's the reason I like the slide and divide method is because now this tells me what the zeros are. Okay? That I have a 0 at negative 5 and a 0 at negative 3 halves. Okay, now the last thing we're going to do is we're going to slide the denominator in front of x. So that means we're going to take this 2 and we're going to move it there. So our final answer is x plus 5 and 2x plus 3. So both things produce the same answer. Okay? X box, slide, and divide. And you could use either method you want for doing that. Okay? Like I said, I like the slide and divide better because when I get to this point here, if it's a situation where I'm looking for zeros, okay, then I've got my zeros already. Okay? Instead of having to solve to get them, I know what they are because they're the opposites of these. Right? So let's look at another one. Have any of you seen that before?
Yes, last year.
That's slide.
Okay. And you did? Okay. All right. Ms. Bundy showed it to you?
I haven't seen it.
The slide and divide? Really? Okay. All right, so let's do another one. Let's do a little harder one. Let's do number 9. Well, if he does, Travis. Okay. All right, number 9. So I'm going to do this one. I'm going to use the slide and divide method to do it. Okay? If you like the X box better, then you can go ahead and do that, but I'm going to go through the slide and divide again. So the first thing we do, number 1, we multiply A and C together. So that means we're going to multiply 8 and 9. What's 8 times 9?
32.
And that number becomes my new value for C. Now, then we factor it. What are the factors of 72 to add up to 73? Okay, 72 and 1. So we have x minus 72 and x minus 1. Okay, so all I did, multiply A times C and factor. Okay. Now I'm going to divide by A. All right, dividing the constants by A. What's A in this case again? All right, so we divide 72 and 1 by 8. And if you want, you can actually simplify and slide them at the same time. Right? So what's 72 divided by 8? All right, so we have x minus 9. And then can I simplify 1/8? Okay, I can't. So I'm going to take the 8 that's in the denominator and move it in front of the x. And there's the factorization. Yes, Tom? No, Tom. Okay. So you can do either way. All right, like I said, I prefer doing it this way. And if you can do it without either of those methods, if you can guess and check quickly to get through it, then I would even suggest doing that, okay, which is a little bit, if your thinking process can go there, then I think you should try to do that. So, yep. Okay, so there's those all factored. All right, so that's to help you get used to what we're going to be doing with our what's called multiplying and dividing rational expressions. So we're going to be doing the rest of this chapter is mostly going to be working with rational expressions, which is basically like the inverse functions. So we're going to be taking our inverse variation stuff, which look like this, and we're going to be changing it around a little bit. We're going to be multiplying and dividing them, adding and subtracting. So basically what we're going to be doing with in this chapter is working with your favorite thing, fractions. Okay? All right. So first of all, a rational expression is what's called a quotient of two polynomials. In other words, you have a polynomial in the numerator and a polynomial in the denominator. 5 over x is just as one example. Here is a couple other examples. Okay? X squared minus 4 over x plus 2, and so on. And so what we're going to learn how to do is to simplify them when we can. We're going to learn about multiplying and dividing them today, adding and subtracting them later on, and then we're also going to learn how to graph them. Regardless of how difficult they might look, we'll learn how we can actually do specifics for graphing them. Now, because we're working with fractions and with variables, the one thing we need to remember is that you can't divide by 0. And so that's going to be an important part of one of the things we do, is the fact that division by 0 is undefined, and so we have to take that into account. All right, so let's look at a couple examples. They want us to simplify and identify any x values for which the expression is undefined. So when we're working with monomials, first of all, okay, those are just a matter of simplifying it, which you guys have done lots of these in the past, and so this is probably not too difficult for most of you. So the first thing we're going to do is take our numbers, 10 and 6. Okay? All right. When I reduce that fraction, what do I get? Okay, 5 over 3, right? Okay. So I put my equal sign, I'm going to put 5 in the numerator and 3 in the denominator. Okay, for my 5/3. Okay. So we have x to the 8th over x to the 4th. Well, we were reminded of that last chapter with logarithms, that what do I do with these exponents when I'm dividing? Okay, all right, we subtract them. So 8 minus 4 is, all right, and that's going to end up in the numerator. So we have 5x to the 4th over 3, or 5/3 x to the 4th, however you want to write it. Okay. Now, the thing is here is they want us to identify where the expression is undefined. And it's undefined when the denominator equals 0. So we're specifically looking for when the denominator equals 0. Okay. So that means I'm going to take the denominator and actually set it equal to 0 and solve. So I want to solve this. So what do I do to solve 6x to the 4th equals 0? What do I do first? Okay, divide by 6. And 0 divided by 6 is, all right, good. So then I'm going to take the 4th root, right? Okay, cube root if it was a 3, square root if it was a 2. But in any count, what number can I raise to the 4th power and get 0? There's only one. 0. Okay? So the answer here is 0. So what I'm going to say is that I'll have this and I'll say x cannot equal 0 because that's where this expression is undefined. And I got that by setting the denominator equal to 0 and solving. Okay. Letter B. Now when I have monomials like I did in A, it's very simple to simplify them. In letter B, if you have expressions with a plus or minus sign in them, you must factor first. Okay. You have to factor first, and this is why we just worked on our factoring. Worked on it yesterday, or on Friday and today, is so that you have a good idea of what to do. All right, so we're going to factor this. So what are the factors of -2 to add up to 1? Positive 2 and -1, right? So the numerator, when I factor, I have x plus 2 times quantity x minus 1. So we factor the denominator. Now one thing to remember is you're always, first of all, looking to see if they have anything in common. Right? And these don't, because they don't all have an x. So what do I get when I factor the denominator then? Kylie, do you have that one? Okay. So x plus 3 and x minus 1. Okay. All right. Great. Okay. I'm looking for common factors then. And here I have common factors of x minus 1 in the numerator and the denominator. So I can simplify this fraction by canceling those out. So that leaves me with x plus 2 over x plus 3. Now, I have to tell where it's undefined. When you tell where it's undefined, you have to go back to the original problem, not your answer. So where I tell where it's undefined, I need to focus on the original problem denominator. Okay? The nice thing, though, of what I've just done is I just factored that. So what makes x plus 3 equal to 0? What number? What? Negative 3. What makes x minus 1 equal to 0? Positive 1. So x then cannot equal negative 3 or positive 1. Because that's what makes the denominator equal to 0. Okay? That's how nice the factoring is. It's just the opposites. Unless you have a coefficient here, okay, in front of the x's. And that's where why I like to slide and divide better, because if you end up in that situation here, you're going to find your zeros right away. Okay? All right. So the first types of problems you're going to be doing is going to be just like this. Simplify and tell where it's undefined. All right. Okay. Example 2 says to simplify by factoring negative 1. Now, when we do these problems, everybody remember what standard form is? You remember what standard form is, okay? First thing we're going to do is we're going to rewrite it in standard form. Okay? Rewrite it in standard form. So that means I've got to bring my negative x squared in the front when I write it. So now, whenever x squared is negative, when you factor, you're going to factor out a negative. Okay? So the first thing you're going to do is factor out a negative. So we're always looking for the greatest common factor whenever we do any factoring. So look at the numerator. What do those two things have in common? Okay, they have an x in common. But since the x squared is negative, we're going to take out a negative x instead of the positive x. If you remember when we were factoring by grouping, we did that, right? Because we said, okay, if terms 3 and 4, if the third term was negative, we're going to factor out a negative. This is the same thing. So then we get x minus 4 here. Okay, so then we're going to factor the denominator. So like I said, this is why we practice that. So the factors of negative 8 that add up to negative 2, x minus 4, and x plus 2. And remember, the order you write them does not matter. So I look to see what they have in common. In the numerator and denominator, they both have an x minus 4. So I can cancel out the x minus 4s. And I'm left with negative x in the numerator and x plus 2 in the denominator. And then when I identify where it's undefined, I'm going back to my original form factored. So that means I'm going to look at, I'm going to look at this part here then. All right. So what makes this factor equal to 0? Okay, positive 4 and negative 2. Good. So x cannot equal 4 or negative 2. In the order you write those two numbers doesn't matter either. Got to make sure you do both though. Okay. All right. So let's look at some multiplication then. So when you have monomials, okay, everybody knows what a monomial is, right?
Yes.
Okay, no plus or minus signs there. Okay, whenever you have a monomial, what you want to do is just multiply them together. Right? Just multiply them together and then simplify after you've multiplied them together. So we multiply our constants together. 3 times 10 is 30. Then multiply the like variables. X to the 5th times x cubed is x to the 8th. And y cubed times y to the 4th is y to the 7th. So just when we multiply with like variables, we add the exponents. Okay. Do that with the denominator also. Now this is just like the first example we did. All right. Put our fraction bar, simplify 30 over 18. So what number goes in both 30 and 18? Okay, all right, so we end up with 5/3 and we divide them both by 6. And then when we're dividing with like variables, what do we do with the exponents? Okay, so in the numerator we're going to have x cubed, and in the denominator we're going to have y to the 5th. Because the y to the 12th is in the denominator, so my answer there is going to be in the denominator. And then notice, in this case, it says assume all expressions are defined. So we don't need to worry about saying x cannot equal this or that. Okay, letter B. With letter B, when you're multiplying and you have binomials or trinomials, okay, then what we're going to do is we're going to write a single fraction bar, and then I'll factor whatever I can. Don't multiply them. Okay? Don't actually do the multiplication. You just want to write them as factors multiplied together. So like with x minus 3, I can't do anything with that. X plus 5, I can't factor them, so I'm just going to write them as factors in my numerator. I'm not actually going to multiply them. I just want to write them as factors. Because hopefully I'll be able to do some canceling with them later on. Right? So in the denominator, I have 4x plus 20. Do they have anything in common? Okay. All right, they have a 4, so I'm going to take out that 4. 4 times x plus 5. Oh, awesome. There's x plus 5. All right. What about x squared minus 9? We worked on them when we were factoring by grouping. All right. What do you get when you factor x squared minus 9? Chris, do you remember? Okay. Freddie, do you remember? Zach? Sean? Trevor? Tom?
What's the question?
What do you get when you factor x squared minus 9?
Oh, x plus 3, x minus 3.
All right, x plus 3 and x minus 3. Remember, that's the difference of two squares. All right? And so it's just like if I had this written down. All right? What are the factors of negative 9 that add up to 0? Positive 3 and negative 3. Okay?
Oh, I remember now.
All right, great. Okay? Now, all right, looking for our common factors. Yep.
So no, not all day.
They have a fire truck at the elementary school that they're doing, must be doing fire safety down there. Okay. All right. So I can simplify it. All right. So what do I have in the numerator now? Okay. We have 1. Does anybody know why? Okay. Good, David. Very good. If anything is divided by itself, it's equal to 1. So really, when I do this canceling, I should put in 1s there and there. Okay, in those places. So in the numerator, we have 1 times 1 is 1. In the denominator, we're left with 4 times x plus 3, which is 4x plus 12. And that's my answer. Okay, you don't have to say where it's undefined, even though we could in this case. 3, negative 3, and negative 5, right? But we don't have to. Okay, that's the last example I'm going to do, but I'm going to tell you one thing because you are going to have a couple of division problems, okay? All right, dividing. How is dividing fractions different than multiplying fractions? Okay. What, Sam? Yep. But what if we're dividing fractions instead of multiplying fractions? The first thing we have to do is copy, change, and flip. Yep. So the first thing I would have to do here would be I'd put my fraction bar, and then I would copy, change, and flip before I did anything else. All right, and we'll look at another one of them probably tomorrow. Okay? All right, but remember on the division ones, copy, change, and flip, and then you do the same as the multiplication. All right? If it has monomials, multiply them together. If it has binomials and trinomials, factor them first. Okay?